corrections. Okay, today we will do the 4 different type of sensor. So the first one is the capacitive, inductive, limit switch, and rotary encoder. Okay, which I already teach yesterday. So basically, the sensor is quite straightforward. For example, like the capacitive and the inductive. Okay, both sensor they only have 3 port. One is 24 watt positive in, one is 0 watt out, and then one is a signal. Okay, then how we need to connect is we connect the signal output to the lamp. That's it. Okay, this is a NPN signal. Okay, that means we will get negative output. Okay. So another one is we also have another connection is the second one is we will connect to the limit switch. Okay, this is a limit switch 0, and then for the limit switch, they only have 2 port. Okay, one is for positive, negative in and out. Okay, and then inside the limit switch, they have 2 choice. They offer 2 choice. One is normally open and one is normally closed. Okay, you can either connect either one of those or both. Okay. The next one, here is some mistake here. Okay, please help me to change instead of inductive, you change to capacitive. But in terms of the circuit, there is all is correct. Okay, just only the word, only the label only. This is the capacitive. So the third as practical that what we try to do is we will connect the sensor. Okay, and then put this one C as well. We will connect the sensor to the counter, and then we will use the sensor to do the counting. Okay, so how we use the sensor to do counting actually is very simple. We just need to connect positive, negative 2 port, and then from the output we need to connect to the counter 0, input 1. Okay. As you can see here, there is a 1 port is input 1. Once we connect, then we power up our counter with 24 watt and 0 watt. This is the common for internal port. This is reset, and then this is for us to set the login value. And for the counter output, we have a normally open and normally closed. Okay, these 2 lights that will do the indications. Finally, we will do it for the rotary encoder. Okay. Rotary encoder. Sorry, this one is you need to delay it. Okay. Just rotary encoder, no A. This one you need to delay it. So for the rotary encoder, also we use the counter to record the pounds. Okay. This is the rotary encoder. And then the output will be connected to the input 1. And then the same also for the counter as what we connect as for the inductance. Okay. So this is basically today practical. We have 4 only. And then I would expect we can finish a bit early. Okay. Then there is additional 1 review question as the previous one. The review question is, I would like you guys to write a report on a sensor, okay, you need to find a video clip on the sensor to tell me what is the working principle, working environments, advantages and disadvantages, all of this from YouTube or any source that you can find, okay? And then you need to submit this video clip on next Wednesday, because I will use the best video clip to do the lecture, okay? So we will discuss in the lecture about the video clip. So I hope you guys can give me the interesting one. If you give me the interesting one, then I will award more marks, okay?
Sure, what do you mean by video clips?
Just a video, introduction about a sensor. There are a lot of sensors available in the YouTube or other resources.
Okay.
I want you to have a case study on the sensor, apart that what I show it to you, okay, from my lecture. Because the sensor that I show it to you in the lecture actually is a little bit conventional. Okay, that one is the very fundamental. Actually, there are a lot of different sensors in this market. Okay, I hope you guys can do a little bit research on the sensor, so that once we found a very interesting sensor, then all of us can share and discuss together. And this is also part of your this sensor lab report, okay? Because since this sensor report, I give you all the result, then basically all of you will have the same mark. So I would like to have some differentiations among you guys. So I need to come up with another small little bit assignment, okay?
The video clip need to put in there.
Yes, you need to put in the report. I mean, in this report, just like the review question, after the conclusions, then you add in the report on this sensor. So the content of this sensor you should have is working principle, working environments, applications, advantages and disadvantages about the sensor. I mean, a report on this sensor. Okay. So I will give you one example later on.
If the clip accidentally same in our friend's house.
Okay, very good questions. Okay, actually I have because as you can see, there are two possible occurrence. Okay, first is your video clip is same as your friend. Okay, but the way you write the reports must be different. Okay, if I found out both reports also the same, then I consider this is a plagiarism. Okay, serious will happen. I will deduct mark from both of you together. Okay, if you have same I mean video clip but different different report, okay, I mean the way that you write will be different, then this will be considered coincidence. Okay, then what I will do is maybe I will minus 0. I give you 95 marks. Okay, 95 marks from the total. I only minus 5%. Okay, if you have the same video, because I really don't know both of you searching for the same video. After that, both of you doing the discussions or whatever, because this is very difficult to mention. Okay, then this is okay. Then they also have cases like you will be, for example, like capacitance. Okay, sensor. Then both of you also found the topic of capacitance, but different video and different report writing. Then I will consider this is okay. I mean, this is no plagiarism at all, because as long as the video is different, report writing is different. Okay, no plagiarism. If video is different but report writing is same, then this is plagiarism. You guys get what I mean?
Sir, so the link, right? When we put the link in our report, we need to explain what is inside the link in the report.
You no need to explain the link. I will put up a folder. All of you, you need to put the folder inside a folder that I provided to you guys by Wednesday. Later than Wednesday, I will consider that one will be late because I want to do a study on all the sensor that you guys provide, and then I want to use the sensor to share among your friends, because after that they will be allowed, because since your total number is 32, supposedly there will be 32 video clip. So I need time to go through it. Okay, I will pick some of it which are good. Okay, I consider it's good that work for us to share. Okay, you get what I mean?
So we
And
need to
then
put the
for-
clip in the report.
You need to put the clip in the report and also the video. You can download you can upload the whole video, or you can put the link. Okay, put the link.
So if we put the link in the report, we don't need to write back what is inside the link. Just put inside only lah. So like review questions, put a link like that only.
You put the link there, and then your name, and then you need to write a report on the sensor that you provided.
So we need to explain what's inside the link lah.
Yes, the report content I already told you. You need to tell me writing your working principle, because I just don't want you to get the video clip. That's it. I want to know your understanding about the sensor. That's why I want you to write it out.
Okay.
Okay. So this is a small assignment in this sensor report, because this sensor lab, they only have 4 practical to do. Very quick, we finish one. Okay. So after that, after I demo this video to you, everyone of you okay? Then I will send you my way of sensor. It's a guideline, so you guys can look at it. Okay. I will show it to you later on. So now we go for the photo first. Okay, who is not in yet? Now it's 11.
Teacher, only Freddy is not here only. Everyone's here already.
Only Ferdy coming in. Okay. You need to make sure Ferdy alert me when he come in. Okay. So we will go for the before we go for the report, the video first. I need to show you the sensor. Okay, this is the sensor. We will going to study 4 sensor. How the sensor look like? Okay, this is the capacitance sensor. Okay, normally this one is covered up by a plastic, and this small thing, okay, actually is the inductance sensor. This is our rotary encoder. Okay, and this is our limit switch. So the limit switch, when this pattern, okay, that hit the limit switch will go down. Once it's go down, they will press the button inside the limit switch. Okay, if you still remember the lecture that I provided yesterday, then you will understand this one. Okay, this pattern will hit this roller, then the roller will go down, and then touch the button inside and trigger the switch. And at the normal time, because this rotating disc, they won't touch the roller here. We purposely make a pattern here in order to hit this roller here. Okay. So this is a plastic component that we want to trigger this capacitor sensor, and this is the metal component that will going to trigger the the inductance sensor. So we will turn around this rotating disc. Okay. Basically, this is the sensor that we learned today. And next is the label. As I said just now, for the inductance sensor, we only have 3 ports. One is 24 volt, 0 volt, and out. Out is what? Out is our signal out. Okay, the output. This is same as for capacitance. And also rotary encoder. Okay, 24 watt, 0 out, and then output. As for limit switch, they are a bit different. Inside the limit switch, there is one port for normally open and the other port for normally closed, and this is for the power in. Okay, this is only for the port. So next, we will look at the video. So we will doing the experiment first. First. Okay. You can see very simple and straightforward. Okay. So what we need to do is first of all we need to get the power positive, connect to the positive inductance and capacitance. And then the output signal, we will connect to the lamp there for the indications. Okay. That's it for one sensor. Then we do another one. Okay, as you can see, we like this one. Okay, when we turn this one, we touch the capacitance sensor. Then the red button color will turn on. Then we use the metal. Then the green button will turn on. This is how we detect the both different material. Okay. Is that clear for you guys? Hello? Any questions? No? Okay, then we move to the next one. The next one is a limit switch. Okay. The limit switch, the way the connection is a bit different. Okay, as you can see, we will connect it through the positive go to the lamp first. Okay, either way is okay. And then we get the power from the negative, and then we will connect to the either normally open or normally closed. And then we get the power from the negative. This is how we do the connections. You can connect either one as long as both of them is connect. I mean the positive go to negative is correct. Okay, now you can see when I do the rotating. So when I use the pedal, they will hit the limit switch. Okay, so the limit switch will go down and press the button. So if the pedal is away, then the limit switch is normally closed. And when we hit it, it will be normally open. Normally open become trigger, and normally close will break the circuit. Okay, this is how the limit switch work. Any question for this one? Guys, any questions? No, very simple and straightforward. Then we will go to the third one. Because this today the practical is more important to open your eyes. Like we need to know that how this sensor is being connected. For example, like conductors, they have 3 ports. They also have NPN and PNP conductors. Okay, two category. So for these 2 category, you need to know how to do the connections. Okay, and also they also possible only have 2 wires connections. If 2 wire connections, we don't much consider on their polarity. Okay, so we as long as we close the circuit, that's okay. But for the 3 wires sensor, you really need to know how to connect, because one will definitely go for positive and one will go for negative. And then the output, you need to know that either the sensor is NPN or PNP. If NPN, then you need to connect to the N. And if PNP, you need to connect to the P. Okay. So the next one we will look at it is we will interfacing the capacitor sensor with counter. Okay, so as usual, the capacitor sensor here, we will get the output, okay, from the capacitance, and then the capacitor output will be an input for the counter, so that we want the counter to do the recording. So now we need to connect the output into the input 1 for capacitance. After that, what we need to do is we need to power up the capacitance. No, so not the capacitance, counter. Okay. So I think you guys need to submit the report today, for practical one.
Sir, after the class, I got a few questions for the lab 1. Okay, can?
Can you can ask me? Are you the one who want to ask me the question on yesterday lecture?
No. I think that's Charlie.
Oh, never mind. You can ask me. Okay.
Hả?
So for this one, we will use the sensor to do the counting. Okay. For example, like last week that I mentioned, we want to do a packaging machines for orange, right? To count how many actually go into the box. So what we need to do is we need to place the sensor. So we are using the capacitance sensor. So we need to place the sensor very close to the orange. So you need to do the arrangement. I mean, you need to fabricate the machine very close to the orange, and then every time the orange drop to the boxes, then the sensor will count. Okay. So for this one, we set at 7. Okay, reset it. So we will do counting. Okay, one time. Okay, second, third, fourth, fifth, sixth. Okay, 7. So once they reach the login value, the preset value, that means the light will turn on. So they haven't reached the value, that will be normally closed. And this one will show the indications to the user that the orange is not done yet. Okay, when they give you the red light, when they give you the green light means human can do the packaging. The orange is there already. Okay, this is how we use the sensor together with the counter to do a very fundamental, simple automation counting for packaging machines or whatever assembly stations. Okay. Any question for this?
No.
Okay, then we will move to the next one. Okay, this one is for rotary encoder. We will connect the rotary encoder to the counter to calculate the pulse. Okay, the pulse is generated. Again, for this rotary encoder, they have 3 ports, and then the output we will send it inside to the counter in. Okay. After that, we power up the counter. Okay, finish. This is normally closed. Okay, when this one is not up to the counting yet, so we reset it. So we will turn it. Okay, as you can see, we turn one round and half. Okay, and then straight away the light will turn on. Then we reset again, and then we turn. Okay, then you will see that because we put around 500 pounds. Okay, so this is what is about our rotary encoder. So I want to let you guys to have a look on this rotary encoder lecture notes, so that you can have a more understanding. Okay. Will be have a LED and receiver. So the LED will emit the light, and then the receiver will receive the light. Okay. So every slot that have in this rotating stick, this here is called a pulse. Okay. That means every time they will emit the light, and then this slot will go. If they can receive the light, they will count one pulse. If they block by the rotating disc here, okay, the wall here, then they won't have the pulse. Okay, so just now you can see that we roughly rotate 1.5 cycle, roughly lah. Okay, 1.5 cycle. So because we want to get 500 pulse, our preset value is 500 pulse. Okay, so can you guess, a very wild guess, what is the resolution for the sensor just now I used? Do you understand what I'm trying to say? What are the resolutions for the sensor that I use? Guys, you know what is resolution? This one. Okay, we know that inside is 360 degree. So I want you to give a wild guess how many slot actually is inside. How many hole actually inside the rotating disc there? Can you get what I mean? Because they rotate 1.5, more or less 1.5 circle. What is the resolution for that encoder? Anyone can answer this? Who can answer this? Faris? Ashraf, are you there or not?
Joe, repeat your question again. Huh? You want to ask about gray code or what?
I want to ask about the resolution for that video, the lottery encoder. What is the resolutions? A wild guess for that encoder. Because that will take 1.5 second. We correct 500 pounds.
That one I don't know. Joe. I don't know that one.
Try Yiheng. Any idea? Guess what guess? I mean wrong also never mind because I want to increase your understanding about the lottery encoder. Zhongjiayan. Where are they? All open then go away. Giant, yes.
Yes.
What is the answer? Derek? Huh?
Yes.
What's the answer? Chai Zhou Wei 1.39 degree. Yes, possible. Yes, very close answer. Maybe you are correct. Okay. Ferris, what is the answer? Zhongji Jian. Zhongji Jian.
Yeah.
Yes.
What's the answer?
Question, sir.
Answer.
The question is, I want to check. I want you guys to have a very rough guess of the resolution of the encoder that I show it to you. Okay. In order to get 500 pounds, I need to rotate one full cycle and a little bit half of it. Okay. I want you guys to give me a wild guess. What is the resolution for that encoder? This lottery encoder actually is very important, especially for mechatronics students. Okay, in the future, a lot of time you will deal with this lottery encoder. Okay, especially for those if are interested in the mobile robot or you want to do the calculating of the length. All we need is using the lottery encoder. Okay, so I need to make sure all of you understand. This is a very fundamental sensor that you need to know. Okay, Zhongji Jian, what you mentioned is correct. Okay, there could be a 0.93, but normally we won't do that. As I say, most probably there will be the 1 degree Celsius, the resolutions. That's why when you see that, when we manufacture it, it's more easier. Okay, when you see that they only can turn a 1 full round and partial half cycle. Okay, that's why I will guess this one will be 1 degree Celsius, the resolutions. Okay, but you give me 0.93 is also possible. I wouldn't say you are wrong. Okay, it's also correct because we really don't have the
Sir, you're lagging.
is what I
Can you repeat it?
want to see your test
Chưa,
your
you lagging
understanding.
chưa?
Uh-huh.
You lagging chưa?
What?
Just now you lagging.
Yes.
You were lagging.
Lagging. Oh, okay.
Yeah. Can you repeat just now what you said?
Okay.
Sorry,
Chai Zhongwei, the answer that he given is correct, but it's a little bit weird because of 0.93 degree. Okay, I wouldn't say this one is wrong. Okay, I will say this one is correct, but but for me, because I also don't know, I don't do the actual measurements. Okay, what I guess is there could be 1 degree Celsius. The resolution will be 1 degree Celsius. Why I say so is for 500 pounds, I just now I mentioned they need to go for 1 full circle. And then when you look at the video, there will be a little bit half of it. Half circle, but not a full half circle. Okay. So my wild guess will be 1 degree Celsius. Okay. You understand or not? Because maybe I will use 1 degree Celsius rather than Mr. Chai Zhongwei they give 0.93. Okay, your answer also correct.
So
What?
it's more convenient to use 1 degree than decimal, is it?
Yeah. Yes, because for what my guess are, because if you want to make 1 degree, there are more easy to punch the hole every 1 degree. There is a 1 slot. You see, as you can see from the can you see the presentation slide here? Guys, can you see the presentation slide?
Yes.
Yes, as you can see, if you want to make it 1 full circle, we need to have 360 degree. Okay, if I put 1 degree per one, it's more easy for me to do the job. Okay, that's why my wild guess is 1 degree. Okay, but in the reality, there won't be the 1 degree. They will using this binary calculation to do the calculating. Because this is just a wild guess only. Okay, we don't have, but in reality, they will need to use this 2 power of 10. Then we need to check how many track inside in order to have this binary answer. Okay, so most likely what is very close to 1 is maybe 2 power of 8. 360 degree divided by 200 2 power of 8 is how many? Okay, wait, I do some calculation. Okay, I think the closer answer will be 2 power of 9, 360 divided by 512, which is 0.7 degree. Okay, that means actually from the video, they move maybe is one round, one full round, and a little bit, one half cycle, a little bit more. Okay, that means they maybe they move up to let me check how many degree. So the answer will if we have how many track inside. If we have a 2 power of 9 track, that means the value that we get is 512. Okay. If we want to get 500 pulses, okay, so they need to rotate 506 round pounds. Okay, if I rotate 2 round. If I rotate 1.5, maybe will be the 0.35, no. Two, 2 power of 9 if we want to check how many track they have for the absolute encoder. Oh, this is for absolute or not for the incremental. Okay, any more question for this one? Rotary encoder? Guys? Hello, hello. Guys, are you listening to me? Okay, this is for rotary encoder. You need to check the resolution, and then because of the resolution, then you will expect how many rounds they will cycle. Okay, and if you want to check the length of the displacement, very simple. We just use 2 pi r, then we will know the length of the displacement of this the rotary encoder. For example, like if 540 degree, okay. I mean, we assume they will go around 360 plus 180. That means it's 540. Okay, 1.5 round. If my r is 10 centimeter, that means how actually in the linear way, how long did this rotary encoder travel? Can you calculate for me? The formula is 2 pi r. If the r is 10 centimeter, that means he rotate 1.5 circle. So I want to know the linear length of displacement. 10 centimeter. You do it in the chart here. 1.5, 1.5 circle. Not 10, Daro. You need to convert it to the metric meter. Centimeter ma, I say centimeter ma. 0.01. Yiheng, so what is the answer after calculate? Zero point 0.0542. You 942. Okay, that means for the rotary encoder just now you see I travel 1.5 round. That means actually in the linear if we cut it off in the linear way, that it already travel 94.2 centimeter or 0.0942 meter. Actually, this is where viewer to travel, especially for the mobile robot. Okay. If we want to make the robot to go linear, through this calculation to calculate how many pounds that we need. Okay, then we will use it to couple with the counter, and then we can use this one to convey our robot. Okay, you can understand or not? If I want to make this robot to travel 100 centimeter, okay, you just imagine the resolution is 1 degree Celsius. If I want to travel 100 centimeter, round that you need. If you want to travel 100 centimeter, okay, then you will expect how many pounds you get. Do another question for this. Okay, Chua Ka Sing, okay, why is it 0.01 centimeter millimeter 1 meter 1 centimeter? So you want the robot to travel 100 centimeter. Okay, give So anyone can do these questions? Okay, this is about the rotary encoder. What is the answer? Wow, Freddy, you joined very late lah. We already finished the experiment. You know what we have conducted? Guys, do you have the answer? Two pi r equal to how many? I mean, one circle you have 360 degree. Okay, 2 pi r equal to how many centimeter? One round you need to travel. What is your perimeter? 2 pi r. Can you do or not this question? Yiheng, what is the 70 point? What is 70.45? How you calculate 70.45? I want to get how many pounds? Yes. 70.45. How you get this? I want to get how many pounds? R is 0.01. Okay lah, I give you roughly the answer. You will get 572.88 pounds. If you make it round, there will be 573. Okay? 573 pounds. If we want to calculate the pounds. Okay, how we do this? Okay. So first of all, we know that 2 pi r 2 times
Nhama chi bay.
yeah, okay. 2
I cannot
times
see
pi
screen.
times r, how
No screen, sir.
2 times pi times r, how much you get? 0. Can you hear me?
Sir, are you sharing your screen?
Hello?
Sir, you're not sharing your screen.
Okay. Okay, guys, can you hear me? Guys, can you hear me?
Okay.
Yes.
Okay.
Yeah.
Okay. 0.0268 centimeter. Okay. 284. That means 62.4 centimeter. That means I know if I want 62.84 centimeter. Okay. Everyone clear? If I want to travel 100 centimeter, then how many pounds that I need? Okay. Then I will use 100 divided by 62.8. What you get? What you get? How many rounds you need to get? Can you guys hear me? Okay, 1.923. Okay, 1.59. Okay, then what it mean? That means you will go around 1.59 circle. If I have 1 pound equivalent to the resolution is 1 pound per 360. So how many pounds you will get? You will get around Okay, 572.4 pounds. Okay, normally it will be like that. There will be a little bit of lag there because we cannot get a very accurate. That means if I want to travel for 100 centimeter, we must go for 572.4 pounds. Okay, so in this case, you will get this pounds. Okay, this is how we will calculate. So what we need to do is we need to set our counter to receive 572 or 572.4 or 573. Okay, because we are more close to the, 0.4 is more close to the 572, so we will set 572 pounds. That means you set 572 pounds, then the robot will travel 99 plus degrees Celsius, the meters. They cannot get exactly 100 degrees Celsius. Okay, you understand or not, guys? Okay, that means we need to get 572 point something 72 pounds. We need to set our counter, okay, to 572. So if we want to increase the accuracy to 100 centimeter, what can we do? Any suggestion? Huh? You need to increase what? More resolutions. Huh? Correct or not? You need to increase more resolutions. Maybe your resolution you need to increase to 0.5. Then you will get even more pounds, 100 centimeter. Can you get me? This is how we use the rotary encoder. Okay, Chua Ka Sing, what you don't understand? Chua Ka Sing? What you don't understand, Chua Ka Sing? Chua Yi Hing? Maybe you can explain to Chua Ka Sing on your own way. Do you understand what I'm trying to explain to you, right? Mostly, then you discuss with Chua Ka Sing. This is, okay. So maybe okay. Actually, don't worry lah. Inside the tutorial, I will teach you one. Okay, I explain again. Okay, if for example, like if I want a robot to move from one place to another place, mobile robot, that means the mobile robot, then we have what? Then we have the wheel. Okay, the wheel, we will put and how much motor need to rotate. Okay, just like what we see the experiment. That is the wheel, you imagine. And then the radius for the wheel is R. R is 10 centimeter. No, I want to have how many pounds? If in terms of rotation, if I want to travel 100 centimeter, Okay. Can you see that, the question? Why no one? Okay, wait, I'm typing the question again. No, I am sharing in the chat there. I'm sharing with inside the chat. Okay. So if the robot need to travel 100 centimeter in linear, how many pounds you will get based on 1 degree resolution r equal to 10 centimeter? So how many pounds will be generated? Okay, so that means we need to find out 2 pi r. Okay, first of all, we need to find out 2 pi r to get the perimeter. Because this is one round, we will go 62.8 centimeter. So if we want to travel 100 centimeter, we need to use 100 centimeter divided by 62.4. Okay, can you get me? After that, we will roughly know you will need to travel how many cycles. I mean, how many rounds. Then you will get this 1 point. What is the answer? 1.592. Okay, that means you will go around 1.592. Okay, if you go around 1.592, that means how many pounds is generated once? Because as I say, the resolution is 360 degree equal to one cycle. Okay, so how many pounds? Because 360 is equal to 1 cycle, that means it's a 1 pound. So you will get 360 times 1.59. Okay, if you 1 cycle times 1.59, then you will get 572 point something, 572.4. So that means this robot, they will get 572, 572.4, 572.4. They cannot give you exactly 100 centimeter because we only can get round figure. Either you key 572 or 573. So that you need to travel for 100 centimeter. Cannot get, the robot cannot travel okay, very precisely. So if I want to make the robot precisely go to 100 centimeter, what I can do is 1 degree Celsius. Now I increase to 0.5 degrees Celsius. Okay, if I increase to 0.5 degrees Celsius, I will even get more pounds, and then I will more close to the answer. Can you guys get me? Chua Yiheng, do you understand or not? Okay. So for those cannot understand, maybe you can discuss with your friend about this. Okay. So that's all for today practical. The next thing I want to discuss with you is the video. I want to share with you what you need to do for your report. Okay. Freddy, you need to ask your friend because I need you guys to submit one report. Okay. So I want you guys to share a video clip like this.
With thousands of machine learning and artificial intelligence professionals. Keeping this in mind, the University of Texas at
When you get in your car to go on a drive, you often look at your gas gauge, which is a type of a level sensor. Industries use several different types of level sensors to detect their products. Today, we are going to talk about the different types of level sensors used in the industry.
Okay, can you guys watch the video clearly? Okay or not? Watch the video, guys.
Yes.
Okay, good. I think my
Level sensors to detect their products.
okay.
Today, we are going to talk about the different types of level sensors used in the industry. Before we get started on today's video, if you love our videos, be sure to click the like button below. Then make sure to click subscribe and the little bell to receive notifications of new RealParse videos. This way, you never miss another one. Level sensors can be broken into two classifications: point level measurement and continuous level
One
measurement.
is digital, one is analog.
Point level measurement indicates when a product is present at a certain point, and continuous level measuring indicates the continuous level of a product as it rises and falls. The sensors for point level indication are capacitance, optical, conductivity, vibrating or tuning fork, and float switch. The sensors for continuous level measuring are ultrasonic and radar or microwave. We will talk about how they work and which applications are best suited for their technology, as well as their limitations in certain applications. Let's talk about point level indication sensors first. Starting with capacitance level sensors. A capacitance sensor is a proximity sensor that gives off an electrical field and detects a level by the effect on its electrical field. These sensors are small, less expensive than other sensors, invasive to the product, accurate, and have no moving parts. However, they do have to be calibrated and will only detect certain liquids. Capacitance sensors can be used in liquid storage, an ideal use for a capacitance sensor. The next point level sensor we will talk about is an optical level sensor. Optical sensors work by converting light rays into electrical signals, which measure a physical quantity of light, then translate it into a measurement. These sensors have no moving parts. They are not affected by high pressure or temperature, are small in size, and can be used in liquid applications. However, if the lens gets coated or dirty, they would require cleaning. They can be used as low-level indicators to prevent run-dry conditions when using oil, coolant, or hydraulics. Another style of point-level sensor is conductivity or resistance. A conductivity or resistance sensor uses a probe to read conductivity. The probe has a pair of electrodes and applies alternating current to them. When a liquid covers the probe, its electrodes form a part on an electric circuit, causing current to flow, which signals a high or low level. The advantages of using a conductivity level sensor are there are no moving parts, they are low cost, and fairly easy to use. The disadvantages are they are invasive, meaning they must touch the product being sensed, they only sense conductive liquids, and the probe will erode over time. Appropriate use for these sensors would be for signaling high or low levels. Vibrating or tuning forks is another type of point level sensor. They use a fork-shaped sensing element with two tines. The fork vibrates at its natural resonant frequency. As the level changes, the frequency of the fork will change, detecting the level. These sensors are cost-effective and are also compact. They are invasive to the product, meaning they have to touch the material to sense the level. These sensors are easy to install and are essentially maintenance-free. They have unlimited uses based on the material that they can sense. Mining, food and beverage, and chemical processing industries use these sensors for their applications. The last point level sensor that we will talk about is a float switch. Float switches use a float, a device that will raise or lower a circuit as the level raises or lowers, moving the float. The advantages of a float switch are that it is a non-powered device. It provides a direct indication, and they are inexpensive. The disadvantages are can be large in size. Float switches will only give an indication for a high or low level. They cannot measure a variable level. A great use for float switches is in liquid storage tanks for high or low level indication. Now, let's talk about continuous level measurement sensors. We will start with ultrasonic sensors. They work by emitting and receiving ultrasonic waves. The time it takes for the waves to reflect back is how distance is measured. These sensors have no moving parts, are compact, and reliable. The disadvantage of using this type of sensor is that they can be expensive, and in some situations, the environment can have a negative effect on them. The benefits of ultrasonic sensors are that they are non-invasive or non-contact. They are unaffected by the properties of the material they are sensing, and they are self-cleaning because of the vibrations they give off. An example application is a hot asphalt tank at a shingle manufacturing plant. The ultrasonic sensor would be placed in the top of the tank, away from the hot asphalt, and used to sense the level in order to send a fill request for the tank. Radar, or microwave, is also a continuous level sensor. These sensors transmit microwaves by an antenna sensor. The product that's being sensed reflects these microwaves back to the antenna, and the time from emission to reception of the signal is proportional to the level of the product. Radar sensors are not affected by temperature, pressure, or dust. They can also measure liquids, pastes, powders, and solids. They are very accurate and require no calibration. This type of level sensor is also non-invasive because it does not have to touch the product that it is sensing. The disadvantages of radar sensors are that they are expensive, as well as to have a limited detection range. If we go back to our shingle manufacturing plant example, a radar level sensor could be an ideal solution. Much like the ultrasonic sensor, radar sensors are ideal for hot liquid storage tanks. Let's wrap up and review what we talked about today. We talked about 7 different types of level switches and their applications. Some of their applications can overlap, and when deciding on a sensor, it's important to identify the product that you are sensing. Sensors like conductivity or resistance, capacitance, float switches, and optical level sensors can be used to indicate a high or low level, while ultrasonic and radar level sensors can measure your level to give specific feedback to how much of a product is in a tank. Easy to understand format and take your career to the next level?
Okay, guys. Do you see the video?
Yes.
Okay, this is what I want. Okay, I want you give me some video clip like just now that I show you. Okay, and then we will share together, and then we'll discuss the sensor. Okay, and then the working environment, application environment. You need to discuss the discussion about the advantages and disadvantages of the sensor. I mean, this is a very rough report on one particular sensors. Okay, as you know, in this market there are a lot of sensors. Okay, even for me, I also cannot know, I cannot know all, but they do have a lot of sensor available. So I want to open all your eyes as a for lifelong learning. Okay, you guys can do it on your own research and to know more. Okay, and then you will find out some sort like capacitance sensors. If I do a little bit twist and turn there, then I could be used in the water level sensor or even the photo sensor. Then I also can be used. Okay, we can twist and turn or fabricate or invent through the fundamental sensor. Also, for example, like the flow switch. Okay, we just do a wiring connection. That's it. Very simple and very straightforward. Then we can send the level of the tank. Okay, guys, this is what I want you guys to do. Can you get me? Hello.
Yes.
Okay, so I want you guys to present a video clip, do a little bit of research on the sensor. You can do it either way. Okay, either you through YouTube or other resources. Okay, and then you give me the video clip, then we can share together. I will use maybe 1 hour or 1.5, 2 hours for the video sharing, depending on your sensors. And all these sensors, I will give a report. I will give mark. Okay, the weightage of the mark will be allocated more into the sensor report. Okay, that means that is a review questions. So you need to give me a sensor that I never show you before. Okay, all of you can follow, right?
Yes.
Any questions?
No.
No. Okay, so if no, then we will go to the another part of lab report. No, the tutorial, because last week we're not able to finish all because I haven't complete the teaching for what the teaching for the chapter 1. So especially for the PLC that I cannot teach you. Okay, so we complete that one, then we will end our section today. Okay, so now I'm sharing. Okay, go to tutorial 1, questions. Okay, I think we haven't discussed 6, 7, 8, 9. Okay, so for the question number 6, explain the function of a PLC. I think you can get it through my lecture notes. Okay, explain what is mean by a sequential control and illustrate your answer by an example. So this one you can get the answer also through my lecture by using the washing machine as a sample. Okay, example. But I want you guys to give me other than washing machine. You give me one home appliance or production line or what you can think of. They are doing the sequential control so that I can understand whether you understand the meaning of sequential control or not. Okay, I want at least one student to answer these questions. Question number 7, I will discuss with you. And question number 9, I want you guys to do the comparison between the conventional watch and the Mechatronic watch. Okay, in terms of features, size, or mechanism. Okay, so give me the answer. If we can finish this one, then we will end the session now. Okay, quickly. So number 6, I guess you guys can guess the answer from the lecture notes. Number 7, I will provide it later. Number 8, who do the question number 8? Who do question number 8? Guys, who do question number 8? Do you understand or not what I'm trying to say? Do you hear me? Kasrap? Kasrap? Kasrap, do you hear me? Anyone?
Sir, he left. He told just now he left early, right? Before the class on.
Very lag.
He left early. He got things to do.
Okay, very lag. Sorry, because today the connection is not good. So I repeat the questions, okay? So I want you guys to do question number 8 and number 9. So actually, I do have an answer for question number 8, which is washing machine that I posted, okay? So I hope you guys to do another one answer for this one, question number 8, and question number 9 also, okay? Can you hear me? Guys, can you hear me?
Yes, yes.
Then do question number 8 and 9. Okay. Any answer for number 8? Can you hear me? Guys, can you hear me? One example. Can you give one example of question number 8? Trung Wai?